Now that our player and camera are completed, we can start creating the logics that are part of our platform game. And we will start by creating a moving platform. I will start by creating a new 3D object, a cube. I'm going to move this cube here. This cube will stand in for a platform for now. I'm going to increase its size a little bit. I think that's big enough. Actually, let's make it right. I'm gonna take my player and I'm gonna move it all the way to the other side, and our platform. There, much better. So this way I can see the platform, I can test it out. Let's put it around here so we can test jumping on it. And it already has a box collider that is sized to the platform. One important detail is that I need to change the layer of the cube. Actually, let's rename it from cube to platform. So change the layer of our platform to ground. And why is that? Because remember that on our jumping logic, we have a check for when our player is actually grounded, and this check is done with a raycast that looks for the ground layer. So let's say that we don't set the layer to ground on our platform. If I jump on my platform, I won't be able to jump out of it because the raycast will never hit the ground layer. So let's put it back to ground. Okay, we'll create a couple of, actually before that, let's save our platform prefab. And we did a whole bunch of changes on our player prefab. Let's save those changes as well. So back to the player prefab, apply all, brilliant. So we will create a couple of logics for the platform. First of all, our platforms are going to be moving, and so we create the platform movement logic. And we also, as a bonus, do a platform hiding logic. So make our platform appear and disappear. Let's start with the platform. Actually, before we start the platform movement logic, let's just double check our platform should be working. It should be solid, but you never know. So let's just check for a player. It can jump on a platform. It can jump out of the platform. And if we just walk without jumping, we'll fall through the crack. Fantastic. So now let's talk about the logic, and we'll start by creating a new C# script called platform movement. I'm gonna open it up on Visual Studio, and I want this logic to be relatively flexible. I don't want to subscribe to a single type of movement for my platform, from going from point A to B to A to B to A to B. If I want to vary it up, I want to be able to. And I'm going to start that by creating a list of transforms called nav points. That's a new list. Okay. Then I will get a float called minimum distance and a float called speed, which by default is going to be 1. I believe I've forgotten to add on my platform a rigid body. Yeah. So let's add a rigid body to our platform. Head back to Visual Studio, and now I will also create a rigid body reference. And finally, an integer pointing to my current navigation point index. And I will also, let me think, I will also keep a transform of my current nav point and the position of my destination. I'll use these destination and current nav point variables to handle the navigation of our platforms. So on start, I'll get a reference to my rigid body. Set my current nav point to the first point in my list of points. So since current nav point is 0, current nav point index. Since current nav point index is 0, I'm getting the first item on the list. And the vector tree destination is the position of my current nav point, taking away the position of the rigid body. And on my fixed update, let's delete, since we're handling the rigid body, we're going to do it on fixed update. On my fixed update, I will first check if my distance between my current position and the position of the navigation point I'm going to, it's less than the minimum distance. That means that I've reached the navigation point. So I'm going to update my navigation point index, which is going to be equal to current nav point index plus 1 modulo nav points dot count. So meaning if I get to my last navigation point, my next navigation point is going to be the first one on the list. So I'm going to cycle through the list of navigation points. Now that I've updated the index, I'll update the navigation point itself. And I'm going to update my destination to be the position of the new nav point, take away my position itself. Once I've checked that, I can finally move the platform itself. And to do that, I'm going to create a vector tree, which will be my destination array normalized. So with its magnitude kept to 1 times the speed of movement times time delta time. So that's my movement vector for this frame. And then finally I do a rigid body move position with the position of the rigid body adding the movement vector. I'm gonna save it. And before adding the script to the platform, I'm going to just do one more setup here in my rigid body. I'm going to set it as kinematic since I'll be moving it myself. I'm going to set the collision detection to continuous, and I'm going to freeze the rotation of the platform since I'll only be moving it. Now I'll add the platform movement script to my platform, and now we need to set the navigation points. So let's zoom out a little bit. I'm going to move my platform around here, and I'm going to define 3 navigation points, move my platform in a triangle-like movement. I'm going to create an empty child game object of my platform, going to call it nav.1. Add a tag to it since it's an empty game object and unparent it. I'm going to duplicate this navigation point, set navigation point 2 around here, duplicate navigation point 2, rename it to 3, and I'm going to position it here. So a triangle, as I said, a triangle-like movement. I'm going to do some housekeeping, create an empty game object just to group the nav points. Okay, and now back to the platform game object. I'm going to populate my nav point list with the 3 nav points I have just created. I gotta set the minimum distance to 1, and by default let's leave the speed at 1 just to see what happens. I'm gonna press play, and now my platform is moving a little bit slow. Let's try to jump on top of it. There you go. And now we will notice one slight problem when my platform changes the movement. I'm going to increase the speed a little bit so you can see better. You see that as the platform changes direction, my character is sliding on top of it. Right? That's because of a lack of friction between my character and the platform. To prevent that, what I'm going to do is I'm going to first of all create a new folder, just keep things in order, called physics materials, and I'm going to create a new physics material. I'm going to call it platform material. I'm going to change the frictions to 30, a high value, and the friction combine will always use the maximum. Back to my platform prefab, and I'm going to apply this material to the box collider. Now I'm going to press play. Actually, let's change the speed already to 3. Press play and see what happens. There goes the platform. I'm going to jump on top of it. And now there are no more sliding of my character from the platform, and we have a moving platform. Now, let's create a platform hiding script. So I'm going to create a new C# script, call it platform hiding, just in case I want to do platforms that show up and hide in time. Let's open the script. And this script is relatively simple. I'm going to start by creating a couple of variables. First one called show hide time. Let's set it as 5, and a show hide time variation. Set it to half a second. Then a Boolean flag. And let's initialize it on start, just to mark if my platform is showing up or not. And then I need references both for the renderer and the collider. Great. Now on start, I also get reference to these two components, the renderer and the collider. And I don't need an update function here, but I do need a coroutine. So I'm going to create a enumerator show hide platform, and I'll have a while true because this coroutine is going to run as long as the object exists. And here I will wait for seconds, wait for a time that includes the show hide time plus a random value between minus show hide variation, show hide variation. So if you want to add a variety on the time that the platform shows up and hides, you just set this show hide time variation variable. If you want the time to remain constant, you just set this variable to 0. Once these once this time has passed, and then I check if I'm hiding, I'll set the renderer to true and the collider to true as well. Otherwise, I'll set the renderer to false and the collider to false as well. And once I've done that, I just invert is hiding. And then, since this is a while true, I'm just going to keep inside this loop until the platform, until the game object no longer exists. So let's add this script to our platform. Let's put 3 seconds and half a second, and let's see how it goes. I'm going to press play. There's my platform. It should disappear in a while. It did not, and that's because I forgot to start the coroutine. So let's go back to my start and call start coroutine. Show hide platform. Save it. Back to Unity. Press play. Now the platform is appearing and disappearing. There we go. It's going to hide again. There it is. So now my platform is, and you can see on the right, on the inspector, you can see that the box collider and the mesh renderer are being enabled and disabled. Great, so we have the logic for a moving platform in our platform game.